All right. We're going to be connecting out to our systems here, so I just want to make sure that it is working. Thomas Domitrovich here, coming to you live from actually up in Canada, and we are talking about, we're here at a conference for, oh, we got Robert from Omaha, excellent. All right, everybody, so we are, I'm live right now from Ontario, Canada, up here at Niagra Falls. Nehad El-Sherif will be joining us. He is actually speaking right now. They're running a little late on schedule, but that has never stopped. You should be giving them more too. Yeah, that is never, thanks for joining us, Robert. That has never stopped this program from going live. So today's discussion, live from Ontario, Canada, is going to be around a few topics. I want to talk a little bit about the the NFPA annual meeting that occurred last week. And I know I did a recording last Tuesday, so we talked a little bit about that meeting. I want to talk a little bit about the results of that meeting. And then I want to speak a little bit about the IEEE paper that I presented today. Nehad will hopefully come in probably about 30 minutes from now, talk about his IEEE paper, and we'll take it from there. And so we're going to talk about industry news and industry things that are going on. And you know what? You know when it starts? It all starts now. All right, we got Ryan Jackson in the house. Ryan, you ought to see this setup. Yesterday, I got into Ontario, as soon as I came across the border, things went haywire with all of my electronics with regard to connecting anywhere. It was spotty. I had one bar. I did manage to post some things. Nehad and I took a walk last night down near the falls. I saw my bars go up. We were able to, we didn't know if we were actually streaming or not, but we did. Things were just not reliable for me yesterday, but today, we figured it out this morning, got up early, and we figured out how I was going to do this because I wasn't sure if I could even post a video recording it here because my bandwidth was just that bad, but everything is going good. So we got Robert, we got Felix Sandoval, good morning or good afternoon, wherever you are. Hope all is well. So, let's talk a little bit first about it because I got to see Ryan. We got to see a lot of people at the NFPA Annual Conference, I guess they call it, annual meeting. It was just great to get back in person with everybody, break some bread, have some beverages, and communicate like we always did before. So I really enjoyed actually getting back to in-person meetings, although I'm a little spoiled, as many are, about having a normal life that doesn't require being in the air and out in hotels. But it was a great meeting last week. So let's talk a little bit about some numbers. All right, so we had, if you just think about the overall, I'll tell you how many certified amending motions that were passed during the floor meeting. There were 18 certified amending motions that were passed from the floor. Now, let's talk a little bit about that certified amending motion. When it is passed, William Snyder, live again, brother, and we're international. I mean, literally, I'm international now, right? So I'm in a different country. So it is just Canada. I mean, we're like brothers and sisters, but that's okay. So 18 certified amending motions. CAMs, I'm just going to read all 18 of them off. You can always pause, but you can get your pencil out. I'm going to read the 18 CAMs that were passed. Now I'm watching that door because Nehad's going to come in anytime. CAM 82, CAM 105, 128, 63, 83, 85, 120, 115, 117, 107, 49, 51, 53, 55 and 56, 48, and 57 and 58. Those are the certified amending motions that were passed from the floor. Now, what you needed from the floor was a simple majority, okay? They had a few certified amending motions that were pulled. Some of them were pulled right from the floor. And when you're at the meeting and a certified amending motion by the person who submitted them, who pulls that, usually does it for a few different reasons. A major reason is if, for example, if I had 6 certified amending motions on the same topic in 6 different areas of the National Electrical Code, and the first 3 didn't pass, then I probably don't want to waste everybody's time with the last 3. So, and I think we saw that with a few of those who pulled their certified amending motions. There was one no-show. I can't remember which one that was, but I have a spreadsheet that I can tell you that. There was one no-show. 2 pulled by the submitter before the meeting. Okay, and then the following CAMs were pulled and not voted on. So here's all of those that were not voted on. 17, 60, 74, 75, 76, 77, 91, 96, 97, 116, 119, 121, 123, 124, 127, and 129. Those were not voted on from the floor. It could have been because they were pulled, it could have been because they were a no-show, it could have been because they were pulled before the meeting or during the meeting. So for one of those reasons. Now, these were the close votes. So there were a few certified amending motions that either passed or failed with a small margin. And I'm going to give you 1, 2, 3, 4, 5, 6 of them that I think are notable. CAM 167 passed by 46 votes. CAM number 70 failed by 10 votes. That's pretty doggone close to fail by 10 votes. CAM 126, now CAM 126 was copper clad aluminum, okay? And the first, I believe this was the first certified amending motion that was reviewed after lunch. And when I looked at the numbers, see CAM 126, let me open up my spreadsheet. CAM 126, there were a total of, so you had 196 and 198, 12, 14, 10, 19, so about 390 some people in the room at this point after lunch. So 390 some people, and I'll just give you an example. Total 395 people, and I'll give you an example. Before lunch, we had 566 people voting, right? So if I look at the number of people who were voting before lunch, these are the total voters: 500, 545, 561, 543, 558. 536, 576, and then you get after lunch and you're at 395. So I think it would be safe to say that there were probably some people who were still out to lunch, okay? But in any case, that first certified amending motion saw it pass or failed by 2 votes. How would you like to have to come to that meeting, have your certified amending motion come up and have it fail by 2 votes? You know what you would be doing is looking around and saying, okay, you know, all your little buddies or whatever, you know, did you vote? No, I forgot to vote. Or if your 2 friends were out to vote, or 3 friends were still out to lunch, and you were sitting there at the microphone, I think you'd have a few choice words for those 3 friends. But in any case, 2 votes, it failed. CAM 128, again, copper clad aluminum, passed by 53 votes. CAMs 115, certified amending motion 115, which is on 495.4, passed by 18 votes. And then CAM 118 on Article 700.5 failed by 34 votes. So that was, some of those were kind of close. Two other ones. So I'm going to call out the biggest winner, And I'm going to call out the biggest loser, all right? The biggest winner was CAM 85. And I'm just going to join. So CAM 85, Certified Amending Motion number 85, was it was the recommended text for section 353.48 on joints. And the submitter of this one wanted to add the words, it says all joints between lengths of conduit, and he wanted to add the following phrase, and between conduit and couplings. And then the rest is, this language is existing. Fittings and boxes shall be made by, and they wanted to add an approved method, not just a method, but an approved method. And then he wanted to remove the rest. Identified by the manufacturer, so that's coming out. And they wanted to remove heat fusion or butt fusion joints shall not be permitted. So that text by the manufacturer and the text about heat fusion or butt fusion, they wanted those to come out. And they wanted to add an informational note that HDPE conduit can be joined using either heat fusion, electrofusion, or mechanical fittings. So that was what this certified amending motion was looking to do, and it passed. It passed by a whopping 351 votes. So CAM 85, let's look at the spreadsheet. CAM 85, and I believe that was early. Was it early? CAM 85, the vote was, there were only 10 people who voted against it. Only 10. So that, I think, was the biggest winner, okay? Now, the biggest loser was CAM number 39, which was on 210.8B, exception 7. So CAM number 39, let's take a look at what that was. CAM 39. You gotta love this. I mean, I felt like I was sitting there in Vegas at the race, just coming up with your ideas. What do you think it's going to be? So CAM 39. All right. So here's what CAM 39 wanted to do. We're in 210.8B at this point. This one wanted to add an exception. We got Willie Snyder, Ryan Jackson. I'm just looking. Oh, Dawn Ganier's in the house. Good to see you, Dawn. Okay, so this was the add an exception number 7, which would have said in areas covered by list item 10, and what is list item 10? Garages, accessory buildings, service bays, and similar areas other than vehicle exhibition halls and showrooms. They wanted in the areas covered by list item 10, receptacles greater than 20 amperes installed and labeled exclusively for EVSE. That's electric vehicle something equipment. SE. So EVSE. So they were looking to. Here was the challenge. A few people went to the microphone on this one. I'll tell you the full vote for CAM 39. The full vote for CAM 39 was, where's it at? CAM 39. Here it is. Oh, it was early. So 26 people voted for it. 517 said no. And that's a spread of 491 votes. That's pretty big. So that was the for and against on that one. So only 26 people supported it. So here was the challenge. I don't know if I recorded. Nima spoke against this one. So here was the discussion points that I've heard from a NEMA perspective and from inspectors. And I think a few inspectors that I spoke with, I think pointed out very well that when you have a receptacle outlet that's greater than 20 amps, it's really hard to say that, and even if you labeled it for use with electric vehicles only, remember for a lack of a better word, the pinout for that receptacle is is not unique. It's not like you would say only an electric vehicle would be able to be plugged into that receptacle outlet. Anything. A welder's, anything could be plugged into that. And GFCI protection should be afforded for those other appliances. So I think the problem with that language was the ability to keep it, to make it unique. That was the issue with that certified amending motion. So, but NEMA spoke against it, and I believe its charge point was speaking in support of that certified amending motion, and it just did not pass. I mean, it is on my biggest loser cam. So that was the extreme. So I plan on doing a play-by-play session that will be available for IAEI members only. So stay tuned for that. I'm going to create a short video that will go over all the certified amending motions, what their vote structures were for each of them, who was, I'll try, some of these we captured who was speaking for and against, but I plan to do a blow-by-blow on each of these to help you understand what those results mean. So now I know what you're asking, or you're thinking to yourself, now what's the next step, right? So I'll give you an idea for what happens next. So for a lot of these, Nehad, he's getting a round of applause. So Nehad's going to be coming shortly. So before he gets here, what happens on most of these certified amending motions when they pass, if they seek to change the language, it will go back to the code making panel, and the code making panel then has to vote. They're not obligated to accept it, right? So it could be that you have something that passes from the floor at the annual meeting, and you think, okay, great, we got it, and we're done, and we're leaving, and we're out of here. Well, now it's got to go back to the code making panel, whichever one's responsible for that section, and they could still say they don't agree with you. I mean, that is a possibility, but it does carry weight that just the sheer number of votes and the fact that the general membership at large support the action, right? So now, if you'll notice in the information that was provided to everybody, you'll see in some cases, and I don't know. I don't have. Oh wait, maybe it's out here. So if you go to the NFPA webpage, you will see some of these that will say no ballot or not balloted. And what that means, I'm just looking to see. It's in a different report. I think what it is it's in the. If you go up to the NFPA website, you have to look for the report for the agenda for the annual meeting. And in that agenda, you will see the CAM number, and then you'll see dialogue or text that says not balloted. What that means, if the certified amending motion was to remove language, it's not getting balloted again from the code making panel. You go back typically to previous language. Now, the NFPA process, there's the, what do you call it, there is a document that governs the rules and regulations with regard to the process. That document, there's a table at the end and there's text in there that will help you understand what happens. It tells you who is able to make, what NITMAMs can be certified, who has the right or whatever to make a notice of intent to make a motion that then becomes certified. Sometimes they won't certify it because you may not, based upon what you're commenting on and how you're commenting on it, then they may not support it. So be mindful of that. But that document, that regulations governing the development of NFPA standards, and what I'll try to do is edit this video and after the fact and put that link. I probably should have put that link down below, but I definitely know I'm not going to do that because you know where it's at? It's on last Tuesday's event. go back over to last Tuesday's YouTube video where I talked about the annual meeting. I have all the links down below on the regulations from the regulations guide, and also I have I guess I'd call it the code of conduct, or what goes on at the annual meeting. So check that video out. Don't forget, go back and look at it. You should be watching these anyway, all the time. Right, Ryan? Excellent. All right, so I'm just looking at, I got my computer down here. This is the first time I did this setup, and I did this because Nehad's going to be joining us shortly. Okay, so that is the amendments. So now let's shift gears a little bit. Let's chat a little bit about, come on in, Nehad's coming in now. There he is.
I made it. Sorry for being late.
I heard so I heard Nehad, everybody in there clapping.
You didn't hear people yelling and screaming?
I didn't hear
this
people.
This guy sucks.
Set your bag down.
Stop away.
So I'll tell everybody what I did. So what I've already done is I've talked about the annual meeting last week.
Yeah.
Okay.
Perfect. Sorry for
So
being late.
there it is. So step up here.
This way? Yeah.
Yeah. There we are, right there.
I just look on the computer. The camera's on.
Yeah. So this is the IEEE Institute of Electrical and Electronic Engineers Pulp and Paper Industry Committee. So this is the pulp and paper industry. So if you have a paper mill, if you make paper, if you deal with paper, then you're an engineer, but you don't need to be an engineer.
No, and Mike Doherty and I just presented a paper on safety. So electric safety touches everywhere. Like it can be applied. Like we did the same paper at the electric safety workshop, the one that you chaired back in Jacksonville.
Yep.
I was in Egypt at the time, so kind of did like like a remote presentation, I want to call it. You guys called me in. But I guess so. Maybe quick review of IEEE.
Well, why don't we do this?
IEEE.
Let's do this first. Who the heck are you? I mean, these guys. This is on the IAEI's channel. So why don't you?
I thought you made like an intro.
I didn't do an intro.
Seriously, I sort of like the guest, like should have like a fashionably late. So I should be already introduced. Okay, my name is Nehad El-Sherif. I'm an electrical engineer, professional engineer. I'm based out of Saskatoon, Saskatchewan. I got some questions, so I guess I have to clarify. I was born in Cairo, Egypt. I didn't move to Cairo when Tom and I were, if you've been watching Tom's channel over the last 18 months, I was there visiting with my mom, and she wasn't doing very well. Now she's much better. I've known Tom for, I don't know how many years, maybe 10 years now.
Oh, at least, yeah.
We've been really good friends. And
what code making panel are you on?
Code making panel 2, the best one.
Panel 2. And how about in Canada? You're involved with codes and standards.
Z462, which is 7E equivalent, the electric safety, electric safe work practices.
Yep.
Yeah, I was confused because the 7E has a different name than Z462, but both of them, the bottom line is, it talks about electric safety practices in the workplace.
Right. And that's the stimulus for, and your point was that electrical safety is no matter where we're at,
everywhere.
We have to think about electrical safety, and that's why it's even as critical, or it's just as important in pulp and paper as it is anywhere else.
And it's the reason that this paper, we are representing the same paper because the audience is different. So you have some I guess safety professionals, engineers that go to ESW, but not everyone from the pulp and paper industry go to the electric safety workshop. So we try to, I guess, spread the word because it touches everyone's life.
Absolutely. And that's the importance of what we're doing with the IAEI's channel. What we're doing here is we're spreading the word. We're trying to help people understand how important electrical safety is. So now, your title of your paper that you just gave, what is it?
Human performance, electric safety workplace, yeah. So, I guess, like a quick overview, I don't want to take a whole time with the paper, but you can read the paper, reach out to Tom or myself, and send you a copy of the paper. You don't have to be an IEEE member to get. I have my personal copy that I can share. And the whole idea of human performance is people make mistakes. No one is perfect, right? We make errors. You can just simple errors, I don't know how many times you just gonna write your old phone number by mistake. It's like, oh, this is not my new phone number, it's the old one, or a new old home address or something.
Right.
Mistakes like that, but this could have more serious implication in the workplace, right? If you're working, let's say, forget to lock out, tag out, or forget to turn off, or let's say turn off the power on one piece of equipment, and then you end up working on an energized one, thinking that it wasn't live, like all those little things. We need to make sure that these are human performance or human errors. So there are what we call error precursors that would have to do with the person or the workplace, and there are tools to address those, like they call them human performance tools, or in the nuclear power industry they call them event-free tools.
Yes.
Of course, you can, and we will never be able to get an event-free or like an instant-free workplace, but we sure can try to get as close as possible to zero. I mean, because every just don't. I mean, the problem. I know, and I talked about this many times.
Yeah.
The problem when people look at statistics. Oh yeah, we have like a 10% drop, but still not enough, because these numbers are lives that we lost. It's fatalities, right? People. This could be your son, your grandson, your father, your mother, your wife, anyone, like your neighbor, like your buddy, your best friend.
Yep.
So this is where we have a problem, especially on panel 2, when we talk about, we need to make a change in the code because we can't make the change because we have no bodies. And like, why do we have to wait until there is a body? Because, I mean, I don't think people would say this if they get into the right mindset of this body could have been someone they care about.
Yeah. When it's close to you, it really makes
it makes a big difference. So, because I just said this in a presentation, we dropped, the pattern is dropping over the last 10 years, but we're still not good because I think it was ESFI, the Electric Safety Foundation International, they're talking about in 2019, I guess the most recent data we have in our paper, that there's 164 fatalities in the workplace. And if you think about it, how many days do we have? 365?
Yeah.
This is very, very close to losing a person or having a fatality every second day. Very close to losing a person every second day. So I don't think this is acceptable. Like, don't think of 165. We dropped from whatever to now we have 165. It's like one person loses his or her life every second day.
Yeah. Due to electricity, and we're in the business of we want, think about what's the goal of the National Electrical Code, 70E, 70B, which is moving to a standard, is
CSA is the Canadian Electric Code, CEC, Canadian Electric Code, and 0462. It's all IEC standards, everything. It's just like make sure that those guys, all of us end up going home safely to a loved.
We don't want to lose lives due to the use of electricity. So, and we've all heard this before, and I've heard this where like you say, I've heard the statistics. Well, they're 165, and then you'll hear only 165 people, and and then they'll put the quotes. And really, I agree with you 100% that one person, if it means someone special to you, it means something special.
I think this reminds me, I think you probably remember this in San Francisco, it was PCIC. My first special purpose GFCI presentation, which we'll be talking about shortly here, based on what we're planning. The first presentation I ever did on the topic was back in 2014. And around that time, I believe we were almost losing one life per day. So we're losing a worker every day. So yes, under 10 years, yes, someone, if you're looking at just considering the absolute numbers, you drop from 300 some to 164, we're doing great. But you're still losing a life every second day versus losing a life every day. Is this acceptable? I would say no.
The progress is good.
There is progress for sure.
The progress is great, but it means we still have to do more. And unfortunately, there's a lot of installations that are out there that even if we change the National Electrical Code and you make other changes on installation requirements, you're still not hitting that building that's been around for the last 50 years. So that's why 70B and 70E and
NEC and
there's other 1078 and 78 for inspections, NFPA 73 for residential.
Standards out there.
Yeah, so all of these other documents and awareness have to go to looking at existing structures.
But to your point, Tom, this is kind of what Mike and I were trying to drive through this presentation. We have the one big thing that you take away when you go back to your paper mill or your workplace is to make sure that you try to integrate human performance tools, how to address error precursors like the conditions in the workplace that could be the perfect storm that could lead to a human error, an instant. It could be a shock or a fatality, unfortunately. So we try to our message was try to integrate this into your daily work practices.
Right.
Like if it comes to design, maintenance, or inspection, whatever the case may be, right? Even if you're writing procedures, like if you make a mistake, like an error in a procedure, this could jeopardize someone else's life because there'd be a person who would just take this procedure, who's just starting a procedure. It's just not going to be, I'm not dealing with like this. It's not even life work or anything. I'm not dealing with electricity.
Right.
But just think about it this way: if there's an error, simple error in the procedure, this could cause someone else to lose their lives. Like Mark Zawatsky, he's the chair of our conference. He just shared with me a story. It was a sad story yesterday that he said his electrician moved the wire in one of the paper mills, and 2-3 days later, someone was killed because of that wire, because something became energized that wasn't supposed to be energized, and the poor guy, after 3-4 days, because of this wire that got moved, just came in contact with a piece of equipment thinking it was de-energized because they did their isolation switch, whatever.
Right.
But because of this wire change, goes to your message of the one-line diagram. Something changed in the system, right? And just 2-3 days later, no one even thought, like the electrician didn't even think he did something major.
Correct.
But just under a week later, it just killed someone else.
Yeah, and that's what
sad, right?
what typically happens. You make a change like that, and then you have something that's energized, and it takes time for someone to accidentally touch it.
Right.
And it could be days. Sometimes
It could be years.
Yeah,
I never
it could
know,
be
right?
years. Absolutely right.
And so my co-author, Mike Dorian, I kind of truly believe that we, like Tom was saying, we had a lot of good improvement. So we dropped, let's say, from losing a life per day to maybe every second day, but we're getting to the point that it's kind of plateauing. And we think, Mike and I thought that this was kind of the message from our paper, that unless we start integrating human performance errors, it's the Appendix 7E, Appendix Q, I believe, and Z462 is Appendix U, and unless we start getting those tools implemented in our industry, we're not going to be seeing any improvement, because a lot of the incidents that when you do your root cause analysis on those incidents, you can trace it back to some kind of human performance error. So there are tools to address those errors. Hopefully, we can address it. And this is no different than the nuclear submarine, like Navy, U.S. Navy. They're probably the gods of this whole human performance error. They kind of invented the whole thing. Airline industry. We all flew here to come.
Oh yeah, airline. I didn't. I drove.
Yeah, right. You drove. It's so close. It's like it was like three and a half hours for me to fly, not to drive. It was like 24-hour drive. Yeah. But anyways, because I live out west. But anyway, so the airline industry is striving to address all the human performance errors. The healthcare industry is another good example. They just try to make sure that. Because one little error could cause someone.
Well, that's why they ask you your birth date and your name and everything, because they want to make sure that whatever it is they're doing is right on the right.
If you have any allergies, if you have any, I had you remember this was like a unfortunate accident back in October 2019, right? And so I broke my humerus bone here, and I needed I have a metal plate and 6 screws, right? But during the surgery, it wasn't an error from the surgeon, but the way that the location of the accident, he had to kind of move my radial nerve, and so it got scratched. So I didn't have nerve damage because of the accident. It was during the surgery. I spent like 9-8 months trying to move my wrist, because I remember I was like 2019 in Reno with DSW. I was just wearing a splint. And because this nerve, the radial nerve, controls the thumb motion. I could squeeze, but I couldn't kind of bring my fingers back up, and I couldn't move my wrist. So my wrist was like this. And if your wrist is like this, I learned the hard way that it's not functional. You can't do anything. For like 6 months, I couldn't just cut anything. To open a bottle of water, I had to kind of put it on the counter and press it until I had to wear something, and it was really annoying luckily it was in the winter time, but it's kind of itchy. So it's just like a little error, and it wasn't even a surgeon error. I was told that this sometimes happened because the location of my fracture. And the first thing he told me the next day, when I saw him after the surgery, he said, I have good news and bad news. Good news is operation was successful. Bad news, you have nerve damage because of so and so. So I guess my point is, this is something that they see often, but they try not to make those kind of mistakes, because it could, I'm lucky that I got my wrist moving again, but it could have been you just won't be able to have any mobility in your wrist for the rest of your life.
Yeah, that and so that whole topic of I call it having your head in the game when you're working on electricity or you're working in and around energy. And it's not just the electrician. It can be any trade that's out there that's working on a job site. They all have to be aware of the hazards, and that's one of the things we do from NFPA 70E. So take a look at Annex Q in NFPA 70E, and that's the topic that Nehad was talking about, human performance. Now, my paper was on reconditioning circuit breakers, and our message really was that molded case circuit breakers, obviously the National Electrical Code says you can't recondition molded case circuit breakers, but what we tried to bring forward is the fact that there are things you can do to a molded case circuit breaker that is not reconditioning, and you have to understand the definitions. We also talked about the fact that we can recondition power circuit breakers, and I know as a company we do that all the time, and there are a lot of people out there who have older equipment, older circuit breakers. You can bring those right back up to even better than, arguably, better than what they were back in the 50s or 60s or whenever they were made. So there's a lot you can do, and you really have to understand what you can and what you cannot do.
I guess in my mind, not every equipment out there is appropriate for DIY. Like you can just do it yourself kind of thing. Yes, you can do, like Tom said, you might be able to fix it and make it look much better than 30, 50 years ago when it was first made, but this doesn't mean that you'll be meeting a code, because there could, again, some things like very subtle that a person could miss while they're doing reconditioning themselves, because they're not professional or you're not the manufacturer. The manufacturer knows the best when it comes to the equipment.
Yeah, right? and there are a lot of people out there who do that for a living, and what the code tells us for circuit breakers, if you recondition it, it has to be listed as reconditioned, right? And Article 110 has requirements for marking and how to handle the manufacturer, how to handle that. If you recondition it, you have to mark it as being reconditioned, and when you recondition, you have to remove the original listing mark.
The date or something on it as well.
Yeah, you have to put the date it was reconditioned. You have to remove the original listing mark. And I believe in 2023, we just had this dialogue because the motor organizations, from a motor manufacturer's perspective, there's valid reasons why you wouldn't want to remove the listing, because it's a part of the nameplate. So we put provisions in there so that you can obliterate it and make it unrecognizable. So they address those concerns.
It's work in progress, right? But I think we're definitely, the NEC, going in the right direction, because you want to make sure that you don't end up having an incident because someone just tried to fix circuit breaker. There's, like Tom said, there's a list of equipment that you're not supposed to be reconditioning, and there are other equipment that you can. But then when it comes to reconditioning equipment, a legit equipment, it must be done by a professional, someone that knows what he or she is doing, not just, I'm just going to do it because I want to save a couple of $100.
Yeah, now there are instances in the code where it tells you can recondition, but if the code is silent in either regard, that's not saying that you can or you can't. It just says there's no rules on it. But there is a rule that says if you recondition equipment, if you meet the definition, you have to put your name on it, take the original manufacturer's name off, take that UL label off. And if in the code it tells you that it has to be listed, then you're probably going to have to get it listed just because it has to be a listed product. So follow the NEC, and it's important that you do that, because those devices, especially circuit breakers, we rely on those for arc flash reduction. We rely on those to establish an electrically safe work conditions. So make sure you're following the rules.
And the thing is with codes, it's never going to be perfect. That's why we update them every 3 years. So I would argue with everyone listening to us that you don't want to be, there are gray areas, like Tom said. Sometimes the code is quiet. They don't tell you whether, because if it's easy, you're not allowed to do this or you're allowed to do this. This is kind of easy, like you kind of know where you stand. But the gray area is the problem. And I would argue that you don't want to be standing before the jury trying to defend something that you did when it comes to the point. Because some of us, not everyone, but even like if you're not a professional engineer, you don't want to lose your license. You're liable because, in Canada, I had the story of the ring in one of the videos.
Oh, that's right, yeah.
Go watch it. And Tom and I had a few months ago. But in Canada, we have this engineering ring, right? The iron ring, what we call it. And it's just a reminder that you have to make sure that you do your due diligence when you're doing any engineering design, anything that has to do with engineering, because it could impact someone else's life and it could be like another 10 years. Like someone built a bridge. We were just talking about the last night, remember?
Oh, that's
the
right,
bridge
yeah.
that collapsed in 38, whatever.
That's right.
You just build a bridge and you're just off to your next project. And guess what? A few years later, the bridge collapses because it wasn't designed right. And then how many people lose their lives?
Yeah, you know, I think what that speaks to is everybody plays a role, right? And you think about the National Electrical Code and the electrical industry and how we follow the rules. We follow the National Electrical Code, we follow safe work practices. But those wires are in a structure, and that structure has codes and standards associated with it because the architect who lays it out, the engineer, the mechanical engineers, and the structural engineers.
There's soil studies, whatever the cement that they use. There's a percentage of things that they do.
There are so many things that everything is a system. So you may have the most impeccable wire, and you may be the best electrician, electrical contractor, and everything is to code. If the structure is faulty, that jeopardizes our wires. Right. And it can cause an issue. So, and the Tacoma Bridge is a good example of that. There was another bridge here, which was not the Peace Bridge, the bridge right here at the falls, back in the, I would say, was it 50s or 40s?
I think so, yeah, like the one that we were reading about last night. I think it was 38 or something.
38. So back in the
30s, or
back in the 30s, they made an error or of some sort in. Oh yeah, that's what it was. It was the pilings were not deep enough in the river.
Yeah, the river, right? Yeah, right. Now I remember. Because we read the story right next to the picture. They have like a black and white picture and a little kind of write up on what happened.
That's right.
So we were curious, why did this collapse? And I didn't know about it.
Yeah, and there's electric on there too, right? Because there were lighting fixtures and there were like road lights and whatnot on that bridge. And now the good thing about it was they knew it was going down. So
yeah, I think it collapsed before it was officially open to public.
Yeah.
But you don't get lucky all the time.
No, you don't.
This was very fortunate because yes, you lost time and money, but they didn't lose lives.
Right.
You know, the reason for, you can look it up, this iron ring is the collapse at Quebec Bridge. And when the bridge collapsed, I think it collapsed a week before it was supposed to be open to public, but it killed, out of the 80-some workers, it killed 72 or 73 workers.
73
Only 11 survived. I remember the number, 11, because they were working on it and they saw the cracks and so forth. But this kind of goes back to the whole problem. The engineer, like the site engineer, like a project engineer, was a rookie. He just didn't know. He was still naive and had no experience. And unfortunately, the consultant, I believe he was out in Chicago, I guess was like he was highly decorated, got so many awards. I think built bridges in LA and San Francisco. Like he was very well respected, but he was getting closer to the point of retirement, so he didn't really care. He didn't want to travel, so he kind of trusted the young guy. That he just didn't have the experience, so you can't really blame him. So the engineer with the experience, the consultant with the experience, just didn't visit the site, which was supposed to if you're building a project like this. And there was like some bad poor communication. Like some workers spotted the cracks in the foundation. It's like this thing is not, and then it didn't go all the way to the food chain, and human errors, but they're probably under rush. They were like 10 days away from opening.
You could trace the errors. That's exactly it. It's human performance, and the human performance doesn't have to be on a job site. It can be during the design.
Right. And design implementation everywhere. I think one of the statistics that Mike was showing was talking about the highest, the reasons for the highest incidents, and one of them was improper procedure. And we argued that yes, it's not. The human performance was errors, like directly related to human performance errors, was third on the list of reasons for problems. The top one was the improper procedure. And we would argue that this is indirectly related to human performance, because if you have an improper procedure, then someone, just like I was saying, made a mistake, like wrote inferior or an erroneous procedure, right? So we can argue that yes, it's not human error, but we do the root cause analysis, it had to do with human error.
Yeah,
Someone just made a mistake.
Yeah, and you know that's a good point. You know we make lists, we make procedures,
A checklist of things.
and checklist of things. We say this is how establishing an electrically safe work condition. That can be a work procedure that you have to follow.
The
And
lockout tagout. If you have an error in your lockout tagout procedure, you just
that's exactly right. So if you're putting that procedure together and you make a mistake because you were tired, right?
Time pressure, the distraction, like you just like got a text message from someone that,
That's right.
oh, just come over. Hey, buddy, we're just like at the bar or whatever. Where
Yeah.
are you? Or maybe just get an angry message from
home.
Your significant
Yeah,
other.
absolutely
And it's
right.
like, so there's a lot of like distraction and time pressure.
There's a lot
We're
of
behind. We are,
and what do we do as an industry? We to catch things like that, to avoid that human error, you try to get reviews, peer reviews, right?
Yes,
I know as engineers, what we will do, I know when I worked for an engineering firm back in the day, when I first got out of college, we had, if I did a design, then I would hand it off to someone else and they would look at it and they would do, we called it a peer review. Before anybody stamped anything,
Right.
we would do that peer review. So those second set of eyes, or sometimes a third set of eyes, especially the more critical, right? So if you're doing a procedure on lockout tagout for a facility, you might want to have multiple sets of eyes. And don't forget the tradesman, right? Don't live in a vacuum. Many engineers don't include the person who's on the floor who's going to be doing the work.
Absolutely right. Because one of the things I was just sharing with the audience 10 minutes ago or 15 minutes ago is, we talk about the culture and how to establish a blame-free culture, like we don't want to be pointing fingers. And one thing I truly believe in, and I think hopefully most people would agree, is to make sure that you have good communication and just get the buy-in. And to get buy-in from your people, you need to tell them not just the how, the why. Like, okay, you will be doing this. This is not enough because so and so and so. And once you get them convinced, like one example I used during the presentation is documentation. It's very important to document everything. But heck, we're just like under time pressure. Enough time to waste. I'm an electrician, I'm an engineer. Why would I waste my freaking time documenting something? Guess what? We need to document things to learn in the future. We learn from good things and we learn from bad things.
That's right.
So if the individual in charge of documentation is not convinced that this is something important because so and so and so, the why, not just the how, because it's easy. Just give me write a technical report. We all took technical report classes during college or university, and I think I didn't like them, they were boring. But then I didn't, as an undergrad, I did not, I was wrong, and I'm admitting it. I did not realize the importance of little things like soft skills until after I graduated, because as an undergrad, your mindset is, oh yeah, I'm a technical guy. I'll just do the differential equations and the triple integration.
Well, you may have not been wrong that they were boring, because they probably were.
But they're very important.
But
the problem is, again, no one ever taught me, I don't even remember, but the instructor did not tell us the why. It's not the how. Oh, just write, this is how we write the technical report.
And that's,
why would I even bother? I'm an engineer. I'm not a
and we do that. We do the whys, like when we do if you ever sat in an NFPA 70E training class, you'll hear a person talking about the hazards, and they talk about the impact of the hazards to the skin, whether it be shock, arc flash, the burns, the temperatures. Those are the whys to wearing personal protective equipment. So when we do...
To get the buy-in, to convince them to be in this suit,
everybody.
Space suit that is so uncomfortable.
You're getting buy-in from the electrical worker to wear his clothes.
And
you're getting
buy-in
buy-in from to management to actually fund and make sure their electrical workers are following those procedures, and fund the whole concept of establishing electrically safe work conditions.
And build a culture about reporting, because, sometimes, we're all humans, right? Oh yeah, you know what? It was a near miss. No one was hurt, whatever.
I'm an alien. I live with Brian Rock. We're on the Starship Enterprise.
So this explains what, there's so many weird things about Tom, and now I understand that he's an alien. Okay, good to know. Right. So can I get your signature, Mr. Alien?
Sure.
So I know E.T.
No.
TD, like TD and E.T.
No.
Yeah, but I guess the point is, when people understand and know the reason they're doing things,
Right.
it makes it easier for them to do it because they will be in a different mindset. Usually the mindset is, why would I get out of my way to do this? It's not my job. I'm not getting paid to do this. I'm wasting my time. I'm already behind. And we're all behind in a lot of things, right? There's
Absolutely.
always time crunch and time pressure. So if you don't understand or you don't share the value and get the buy-in, it's very important from all throughout the food chain. Like it's just like you get the buy-in from senior management, VPs, CEO, and the frontline worker. Because if you get the worker to buy in, like Tom was saying, I understand the value of PE and it's important, it protects me, whatever. But if management doesn't care or they don't understand the value, then the poor guy's not going to go out and buy PPE for himself or herself.
Right.
We need management. And then if management get the buy-in and they buy the equipment, the PPE equipment, but the workers don't understand the value, it's like, I'm not using it. Just let them. So it kind of, it's a two-way street. You need to make sure that everyone is on board, on the same page, kind of thing.
All right, so we got last 10 minutes, and we promised you we'd talk a little bit about special purpose. And the reason I think Nehad is a great person to talk about the special purpose GFCI is
Someone's
because
just too nice. Don't believe
no, I
him.
mean
He's nice.
you were in a position at one point where you were presenting to Code Making Panel 2. You were educating on what the special purpose GFCI, because you were involved with that product, and I'd like to help our viewers, and again, we're probably going to do a session on this because the 2023 code has some language in it with regard to the special purpose GFCI. But can you give us an overview? What is a special purpose GFCI?
Right. So I guess thank you, Tom, for the compliment, and this will be like a kind of segue for our future program, hopefully. Because I'm trying to get more fans, right? Like it's just like thumbs up and like Tom's
Don't
channel.
forget to hit the thumbs up. Don't forget to subscribe too.
Always an even number. If you dislike the channel, you have to press it twice, four times, 6 times.
Yeah, if you hit the thumbs down, you got to do it twice or four times.
Or like if you have time, 10 times. I mean, whatever, right? As long as it's an even number. But I guess the point is, so in my past or previous life, I worked for a manufacturer. I was on the R&D team. So it wasn't my design, but I was in charge of designing the first special purpose GFCI. And like Tom said, special purpose GFCI, the name is tricky. It's not for special applications. It's just special purpose because UL called it that. The reason they're calling UL called it or labeled it as special purpose, it's not, they wanted to make sure that it's different from Class A.
Right, so it's not a Class A. It's not a 4 to 6 milliamp.
No, this guy is 15 to 20. So it's like, let's say 20 milliamp, particularly like 20 milliamp. Right. And it, Class C, Class D, Class E. Class B doesn't exist anymore. It's obsolete. It's a different story. And Tom and I have a really good article on GFCIs if you're interested.
Yeah, well, we'll get into that, but give us an overview. We're going to get into that during our other segment.
Right, so the special purpose GFCI is simply a different 3 classes of GFCIs. They are not to be mixed with Class A. Class A doesn't exist to begin with, so C and D. And those classes are designed for a higher voltage, so it can go all the way up to 480 volt in US, 600 in Canada.
So up to 480, up to 600 in Canada.
3-phase.
What's the lower range?
Up to you. You can do 120, but it's not on the market. So I think the lowest we designed was 2.8. So it's like a line to ground. But so, and the big difference is, I mean, 2 differences. A, your threshold for tripping is higher, 20 milliamp. So this kind of crosses the let go of, so just just gonna back up a little bit. In Europe, you might be heard or familiar with RCD, residual current devices, and these are the European or IEC GFCI. The trip level.
IEC is your international standards, and it's their equivalent of GFCI is a residual current device, which has a higher threshold.
It has the exact same, like the theory of operation. You have like a current transformer that just measures or is triggered by the differential of current, so you make sure that what's going one way is returning in the same way to the source. Goes to the source, back and back. If you have any current that is returning in a different path, this could possibly mean that someone is the return path. Right. Because like we all know, current electrons, they will leave the source, they have to go back to the source, but they would take any path, not the path of least resistance. Right. The path of least resistance would have the most current, most electrons coming back. But even if you have another path that is really high resistance, there's still going to be some current going through.
And the current going outside of the path, as long as it exceeds the threshold of 15 to 20 milliamps.
It should trigger the device.
It should trigger the
And the reason that this was done, so this was one difference. The second difference is these devices rely on something UL refers to as reliable grounding. So, because this is not designed to protect, let's say, your home a toaster. Like, you don't ground your toaster, for example.
Right.
But an industrial application, that's why, I guess colloquially, internally, my previous job, we call them industrial GFCIs, because they're more...
It's for an industrial environment, not a residential.
When you have an equipment grounding conductor, all the equipment or all the non-current carrying metal parts are grounded. So you need to make sure that there is good ground, and this was the excuse or the reason that UL said, you know what, because of all the accumulating leakage that would just trigger or just cause unwanted tripping for Class A GFCIs. B, Class A GFCIs go up to 240 volt. Like, you don't have 480 volt Class A or 600. So 480 is more US, 600 is Canada, but the concept is if you go to the higher voltage system, higher distribution voltages in industrial facilities, there's no protection. So you would rely on what they call assured equipment grounding program.
Right.
Which is simply you just go around and check your ground every often.
An assured equipment grounding program just makes sure that that ground is there, it's connected. So you're saying that this device actually ensures or will detect if the ground is not there?
One of the requirements to allow the 20 milliamp leakage level is to be able to what we call a ground monitor. So UL calls it ground monitor interrupt. So you constantly checking your ground, and if your equipment, the equipment that the special purpose Class C, D, or E, which doesn't exist, like I said, for different reasons, which we can cover during our special program on special purpose GFCIs. So the device is, let's say, protecting a motor or a pump or whatever the case may be, right? Or a whole bunch of pulp mill machines or whatever, paper mill machines. Once the ground is lost, the GFCI, the special purpose GFCI is required to interrupt power.
I see.
So Class A doesn't do this. Class A, one of the things that we always talk about, Class A, you don't need ground
right,
for Class A to work. It doesn't, like you can have an ungrounded, like the old receptacle.
Knob and tube, you can work on knob and tube, tube conductor, hot and neutral, you don't need the ground, but the special purpose needs that ground.
Because it is monitoring your ground, and it's required by UL to interrupt power and just take this piece of equipment offline when ground is lost, because once ground is lost, you know what happens? It's just like an ungrounded system. There could be a ground fault on the system and no one knows.
Right.
One storm or anyone comes in contact with a metal part that is ungrounded, then this metal part, let's say, could be sitting at 480 volt. So what happens when you touch this piece of equipment? You have 480 volt imposed across the person's body, which will drive current.
What's the voltage that the special purpose tries to limit the voltage across the body to? That's important.
150 volt. This is a UL requirement. I mean, we try to do less, but I mean, so 150 volt is basically the resistance of the impedance of the person multiplied by whatever current going through the person. This will give you the voltage across the person, right? So the standard calls for 150 volt max.
Excellent.
But I mean, the design that kind of worked on back in the day was much lower than this. I think it was like 40 volt or something. I can't remember the numbers exactly, but again, it's just a matter of allowing more leakage current, because industrial environment is different than residential. Like everything in residential is clean, and you can live with 6 milliamp. But I guess my point was, when I talked about RCDs and I guess got distracted, in Europe there are two philosophies, right, when it comes to shock protection. So there's the North American philosophy and the European philosophy. North American philosophy decided to, we're going to go really, really low in terms of leakage current or trip threshold, Class A.
That's your let-go threshold.
Yeah, because we wanted to provide what they call let-go protection. So statistically, I think 90% or 95% of people, this includes women and children, have a let-go of 8 to 10 milliamp. So which means by let go, which means, let's say I grab this wire and it's just, there's a current going through my body. If the current is anywhere less than 8 milliamp, or depending on the body size and if the skin is wet or not, but 8 is statistical, the minimum for children and women. you'll be able to let go, like just disconnect pretty much myself from the circuit. So I don't need a breaker to cut power for me. But when it goes more than, let's say, 10 milliamp, you get to the point that muscle contraction happens because there's stimuli going, like current going through your body, and it's like I can't let go.
Then
you're stuck. You're gonna get like froze, right? Because you can't move your muscles anymore. You lose control. So this is when we need GFCI or a mechanical or a device that would just cut power, interrupt power. So yeah, it's going to be a bad zap, like you feel the zap, but at least you're not going to get into what they call ventricular fibrillation, which means that your heart, because AC current, especially 50, 60 hertz, that are the worst. My understanding is, I'm not a biologist or medical doctor, but my understanding is the heart pumps blood at a rate very close to 56/60 hertz. So when you hit it with AC current, it messes up the pumping of blood, and it gets like a heart like arrest, like your heart is not pumping blood anymore. So they call this ventricular fibrillation. You need a DFAB device to bring it back.
Restart your heart.
Yeah, it's like you're restarting your machine, pretty much.
Yeah.
Right. So this is problematic because if you get to that state, if you're not, if someone doesn't act quick enough, that's just person would lose their lives. And that's why DC doesn't have the same impact because of the frequency thing. Even 400 hertz, like there's some military use 400 hertz frequency.
Right.
I mean, if you read some of the standards, aircrafts and military, it doesn't have the same impact on the heart. Apparently the worst is 50, 60. We managed to pick 50, 60
We managed
hertz
to pick the worst frequency.
To force frequency for our heart. But the point, there are two things we protect people from. Let go, which means being able to let go without having a device or anything that will just interrupt power for you. And ventricular fibrillation protection. Let go doesn't kill you, but ventricular fibrillation would kill you. So back to the philosophy, the two philosophies. In North America, GFCIs provide both let go protection and ventricular fibrillation. This is the reason that we trip at 6 milliamp, 4 to 6,
right.
Because this would make sure that we are less than the 8 milliamp. So even if the Class A GFCI, should be specific, Class A GFCI interrupts power, the person in the circuit can still let go on his or her own.
Right.
In Europe, they went, you know what, we're going to go a little bit higher because we're going to trust our RCD, residual current device, GFCI, European GFCI, we call it that way, and we'll just trip on 20 or 30 milliamp. So,
which is closer to the ventricular
right, so it doesn't provide let go protection because if you can let go, the device is not going to do anything for you.
Right.
But if you get closer to the ventricular fibrillation, which again is statistics, but I mean 90% of human or people will be up to 50 milliamp kind of thing. So 20 milliamp is a good zap and you'll feel it, but it's just not going to be depending on time too, because we talk about absolute current, but time is important. If you have like 20 milliamp going through your body for a minute or two, you're done.
Yeah.
But if it's like a few seconds, yes, there's not enough time for the damage to happen. So European I guess philosophy was to protect only against ventricular fibrillation, assuming that 50 milliamp is the roughly, statistically, the ventricular fibrillation limit for most people, like good health and like you don't have any heart problems, your skin is dry, and all those conditions. Then, if there's 20 milliamp and the device trips, yes, you at that point you're not able to let go, which is no let go protection, but it protects you from ventricular fibrillation. So Class C, D, and E special purpose GFCIs are kind of more towards the European philosophy of yes, it's 20 milliamp. We understand that it's not going to give you let go protection.
Right.
You at that point you won't be able to let go the piece of equipment that you're touching or the wire or whatever. But the device should be able to protect you, save your life, protect you from ventricular fibrillation. And of course, again, this was based on proper grounding that's done in industrial facilities. And it makes sense to have Class A at homes because you have your kids, you have women, you have like people that are not professional.
Yeah,
like qualified, you could argue.
It's at those higher voltages where you don't
because
have
you're expecting a qualified
GFCI.
Individual, like an electrician, engineer.
And you don't have GFCI
at that
Class
level.
A at 480 volts.
And
right?
6 milliamp is not realistic because you can think, maybe someone just watching us think, you know what, why don't we just do 480? Volt
at 6 milliamps.
At that high voltage, the leakage current, cables, like your cable is the perfect capacitor, right? You have long cables, it just there's capacitance to ground, and it keeps charging. And this current, when we say that it's ungrounded system, It's not true because you have the capacitance to grounding your system. It's not what we mean by ungrounded. There's no intentional connection to ground.
Yes.
But everything is grounded because they have capacitance. So it's grounding everything, right? So those capacitances are charging and there's current going through the ground because it's AC, right? Not DC, remember. It's not that it charges and sits. It keeps like charging, discharging, charging, discharging, right?
Yeah.
So this current can find its way through someone's body if the conditions are right for this shock to happen. So 6 milliamp, it's guaranteed that the leakage current on the long cables, wet, moisture environment, dust, it's an industrial facility, right? Even like light commercial, like your Starbucks kind of place, So probably 6 is not going to be enough current. It was just going to keep triggering the device. So that's why UL decided to push it up a little bit like the European standard, 20 milliamp. Provided that you have what they call reliable grounding, and you have to ground, and the special purpose GFCI monitors your ground.
And the chance, if you did have a ground fault and current was going through your body, it's probably going to be much more than 20 milliamps at those voltage levels anyway. So.
And the thing is too, because the class C is a good point. We talked about the amount of current, but we haven't talked about time.
Right.
We can talk about this more in our special program, right?
And we're over time right now, so.
Yeah, of course. So, it always happens to me. But so time, the special purpose GFCIs use the same time trip characteristics of class A, which is what we call inverse characteristics. Simply, this means the higher current, the quicker reaction you get.
Yep.
So if it's like 100 milliamp, you are expected to quick much faster than if the current the device is measuring was 10 milliamps, right?
Yep.
And what this does is we can discuss this more, tries to put you away from ventricular fibrillation because it's not just the current, it's the current, the energy, current and the amount of time that the current persists through the heart. Of a person.
And when we do our program, we're going to have slides, we're going to have diagrams of help you understand that whole ventricular fibrillation and help you understand the difference between a class A and special purpose. So, but for now,
and I guess
we are five.
I don't know if we told people the reason that we talked about special purpose. There are going to be officially in the NEC. Oh, okay, this was before I joined. So
the NEC 2023 has new requirements around swimming pools and there's a definition of a special purpose GFCI, and you're going to learn more about that in our future session.
So we don't want to give too much away. I tried to do this back in 2017 cycle. Yes. I got to cycle, but I mean, it's a good thing. I think it's definitely a welcome addition to safety in general.
Absolutely. So, all right. Well, everybody, we're about almost 10 minutes over now.
I was 15 minutes late, so
he was late, we are going to have to give you more of Nehad and a discussion around fault circuit outdoor protection at a later session. But for this one, right now, thank you for joining in. Thanks for hanging in there for over an hour, and thanks for thanks to you.
Thank you for the invite. I'm sorry for being late, and I don't know. My mom might be watching. She is now over in Cairo, Egypt.
What's your mom's name?
Nehad. It's Nehad.
Nehad.
It's very close to my name, so just say hi to my mom if she's watching.
Hi, Mom.
Probably she is, and Tom is saying hi.
Can you say something? Tell her hi in Egyptian.
In Arabic.
Arabic.
السلام عليكم ازيك يا ماما عامله ايه؟ انا هنا مع توم صاحبي توم Domitrovich. Yeah, she knows Tom very well. I mean, they haven't met, but they know each other.
Excellent.
So just saying hi. I'm sorry about the Arabic. I swear I didn't say bad words or anything. I
love it. So at least we heard some.
We're like an international channel, so we just
we're an international
subtitles.
Absolutely. We got somebody from Egypt. I'm from West by God, Virginia. We're both here in Canada.
I've been living in Canada for 16 years, so I'm calling Canada home by now. But I was born in Cairo, Egypt, because some people ask me, you were born in Turkey and in Pakistan and India? So, Egypt. Cairo.
That's a good thing. It's
like a small city called Cairo.
All right, so we will see you next Tuesday live again on this channel. Don't forget to subscribe to the IAEI's YouTube channel. If you're watching this on Facebook or you're watching this on LinkedIn, get over there to the IAEI's YouTube channel. Hit that thumbs up. Subscribe and hit the bell.
And please share the video, like what Tom is trying to do. I'm just trying to, that's why I'm very excited every time Tom asks me to come and speak, is we try to spread the word. So, it's great that you're watching, liking, but please make sure that you share the...
And no, we're not going to take any barrel rides over the falls. Not going to happen. And Felix Sandoval, thanks for joining in. Truly international.
Thank you, everyone. I couldn't see the comments, but I'll read them now. So thank you, everyone.
All right, everybody, stay safe and thank you for what you do for the electrical industry.
Right.
Thank you for what you do for the electrical
Thank you
industry.
for your channel and for everything that you've been doing.
And
Great
remember
job.
to stay safe and please stay
Healthy. And for
Healthy.
everyone watching, next time maybe they can come to a conference and we have like a bigger team, bigger presentation.
Absolutely. See you at the next IAEI section meeting, Western, Eastern, Southern, or I guess the Northwestern and Southwestern.
There's a Canadian
combined.
section, by the way.
And there's a Canadian section as well. So get to those section meetings. Don't forget to get out there and make sure you get your I guess reservations, right? All right, everybody, take care, stay safe, and please stay healthy. Till next
Thank you.
time. See you.
Yeah. See you.